Okay, in this video, we're going to talk about graphing sine and cosine. And I already set up this page in the last video, so if you haven't watched the end of the last video where you understand the general shapes of sine and cosine, please make sure you do that. I go through this page very carefully in that video. What I'm going to do to start is just remind you about what was said in the end of that video, but again, I go through it very carefully in that video, so you should take a look at that if you haven't already. So here's a graph of sine right here, and then you can see at the bottom is the general graph of cosine, and what we're going to do is transform these just like we did transformations of functions earlier in the semester. We're going to do the exact same kind of thing. So let me just sort of remind you the general idea here. So sine has this general shape because it's tracing out the y values on the unit circle. So this is the unit circle right here. The y value at the starting point is 0. The y value then goes up to 1, right? And so it starts at 0 here and then goes up to 1. And then the y value goes down to 0, and so that's why this part of the graph goes down to 0. And so this first piece of sine is just tracing out the top half of the unit circle, the y values. And then the bottom half of the unit circle is this piece, right? So this is the y values going down to -1 and then back up to 0. So the y values go down to -1 and then back up to 0. And so sine just traces out the y values, which is why it has this general shape, and cosine traces out all the x values. And so again, if this is our unit circle, and this is a graph of cosine right here, the x value right here is 1, and so that's why this graph starts at 1 right here. And then the x value goes to 0 as it traces out the first quarter of the unit circle, which is why this piece goes to 0 on the first quarter of its shape. And then the x value goes to -1 in this piece, and so the x value goes to -1 in this piece. And then when the x value is at -1 here, it goes back to 0 and then back to 1. And so the x value goes back to 0 and back to 1. And so this is just tracing out, again, the x values on the unit circle. And so this is a general shape of sine. This is a general shape of cosine. Where cosine kind of looks like a bowl, where sine does this top bump and bottom bump thing. And what this section is all about is taking these shapes and transforming them. Again, very similar to what we had done in the transformation section. Now, in this particular class, especially when I run it in person, I have students bring their computers in, and this is a very active class where students are participating on their computer. And so I'd like to run this the same way online, which is going to require you to pause the video at some point and try something. So just bear with me on this. I'm going to walk you through it, but please be open to being a little active and participating in this yourself. So this is the next page in the notes. And the idea here is we're talking about transformations of sine and cosine, right? And so instead of just having normal sine of x or cosine of x, we have all these various transformations going on with sine and cosine. And so we're thinking about transformations, and each thing I'm pointing to, the A, the K, the B, and the C, are all transformations of sine and cosine. And they're the same transformations that we saw in the transformation section. And so you should be able to relate it back to that, but this page is all about you thinking about how it's related to the transformations that we've already seen. And so the transformations we've already seen are the ones that are listed right below right here. Right, so these are potential transformations. The ones on the left are the vertical things, right? Vertical, vertical, vertical. And the ones on the right here are horizontal, horizontal, horizontal. And so the ones on the left, the vertical ones, these things change the y values because they do vertical things up and down. So those are y values. And then the horizontal thing are the things that change the x values. And so all of these transformations, again, these are just transformations from the transformation section. And so I think that's approximately page 22 in our notes is where we saw all of these things, right? When you do things on the outside of the function, which these three things do, it does vertical things, so it changes the y value. And when you do things inside of the function like these things do, right, they mess around with the x values. And so those are horizontal in that case. And so I'm giving you the opportunity to explore some of these things. I think it was mentioned, Desmos was mentioned in class when we were doing this transformation section. And so I've created an online Desmos interactive lesson to help you explore some of these things. And so let me go ahead and share my screen to walk you through what I'm talking about here. So here's my video being recorded. If you go to Blackboard, right here and log in, and you go to our homework site, our Blackboard site, and then you go to course documents. Down at the bottom here, there's a link for graphing sine and cosine and Desmos. And so you should click that and go to that link. And so what you can see here on the left-hand side of the screen is we have the general form of sine being graphed with all the transformations included. And this is the general form of cosine being graphed with all the transformations included. And these are the graphs right here. And so these are the graphs that were on the page I just showed you a minute ago. And you can turn them on or off by clicking right here on the left. You can click the blue or the red, and it'll turn the line on or off over here. So this is just a graph of sine then, right? And this is just a graph of cosine. Okay, so let me go back to the page for just a second here. So those are the general graphs. I'll go back to that in just a moment here. But if we're thinking about just normal sine and cosine, so this next piece right here, what are the values of A, B, C, and K in just normal sine and normal cosine? In other words, how do I get from this general form of sine to this specific form of sine? How do I get from this specific form of cosine, this general form, to this specific form? Well, if I want to write this one, right, there's a 1 in front of the cosine. And so this A is a 1 in that case, right? If I look inside this cosine, there's nothing multiplying the x, and there's nothing being subtracted from it. And so it's like there's a 1 multiplying the x, and it's like there's a 0 being subtracted from it. Right? When I look at this general function cosine, there's nothing being added on the outside, and so c is 0. And so the values of a, b, c, and k in function sine and cosine, a in those cases is 1, b is 0, c is 0, and k is 1. Again, I got those numbers because I'm thinking, what do I need to plug into these two functions up here for a, k, b, and c that would give me these functions down here? And what I'm saying is you plug in a equals 1 up here, b equals 0 up here, c equals 0 up here, and k equals 1 up here, and you'll get these two functions. And so these are the baseline values of sine and cosine. And if you change any of those values, it's going to create a transformation. So in other words, in the pictures I showed a minute ago, these images right here, in these two graphs, A is 1, B is 0, C is 0, K is 1. Okay, and when we change those, it stretches or shrinks or moves those graphs around. So let me just write that down right here. So what I'm saying here is these are the baseline values. And any change in these values will cause a transformation. And specifically, it leads to one of these transformations right here, the ones that we're already familiar with from the previous section. And so what I'd like you to do, sort of the next part here, is to go back to Desmos, and I'll show you what I mean in a second, and try to figure out which value of A, B, C, and K is doing which transformation, right? So the potential transformations are these ones right here. And what you can do in Desmos is play around with those values and see which does what. And let me just give you a quick hint before you think about this. A and K are both going to have two things, two different transformations associated with them. And so keep that in mind. You can definitely explore that in Desmos. Let me go back to Desmos again and sort of show you what I mean by that. So when you go back to Desmos, let me just turn off cosine, so we're just looking at sine here. And you can see in these particular graphs, I have A set as 1, B set as 0, C set as 0, right, K set at 1. And so this is the baseline graphs that we've seen on the sheet that I just showed you. And you can see that when you slide the A slider, it stretches the graph vertically. And so A controls vertical stretching, in other words. And so you would fill in on the sheet that component A does the transformation vertical stretching. But notice, I said it does two things. Notice what happens when you make A negative. So as soon as you make A negative, so, making it less than 1 shrinks it. But then when it becomes negative, it actually flips it. And so A controls vertical stretching and shrinking as well as flipping. And so what you would do after you sort of see that right here is you would come back to the sheet, and under A, you would write, okay, well, A does vertical stretching and shrinking, so it does a vertical stretch whenever A is bigger than 1, and it does a vertical shrink whenever A is between 0 and 1. And the other thing we saw is it flips vertically if it's negative. And so it's a vertical flip if A is negative. And so those are the two things associated with this, right? It's a vertical stretch or shrink, and it also flips it vertically. And so then, again, you could go back to, let me do it real quick here. You can go back to graphing sine and cosine and then see what B does. So when you do B, you can see B does horizontal shifting. And so you could fill that in into into the next line in the sheet. And so take a second and think about all of these things. Again, you can turn off sine and work with cosine, but you can see it does the same kind of thing with cosine. You can play around with C and see what C does with cosine. You can play around with K and see what K does with cosine. So really do take a few minutes and practice this. If I do this in class, I usually give people maybe approximately 20 or so minutes to think about this, and so please do try to take advantage of that. And then the final thing that you should look at this page before I come back and sort of talk about the answers are, once you know what these transformations do, we should be able to write down transformations. So if we know what the various components do to the transformations, then we can write an equation of sine that's been shifted up 10, left pi, flipped horizontally, and stretched by 2 using the information in that table. And so after you fill in the table, think about how you might be able to write a couple of transformations based on the information from the table. Again, please take 10 or 15 minutes and try this yourself. Play around with Desmos. That's a nice tool that you can use moving forward. Just pause the video right now and do that. And what I'm going to do in just a second here is I'm going to start filling in this table with the answers. But again, please try it yourself before you do that. Okay, so what you should have seen from when you practiced this yourself, assuming you did, I really hope you did, is you should have, let me just switch back over here, you should be able to see that A does vertical stretching and shrinking, and it flips it if it's negative, we already said that. B does horizontal shifting, C does vertical shifting, and K does horizontal stretching and shrinking. And the other thing K does, if it's negative, notice that if it gets close to 0, it stretches, but then as soon as it goes negative, it actually horizontally flips things. And so let me go back and fill some of those things into our table here, what we just found, or what you should have just found. So B does horizontal shifts, and specifically it'll go right whenever B is bigger than 0, and it'll go left whenever B is less than 0. C, we said, does vertical shifting, And specifically, it'll go up whenever c is positive, and it'll go down whenever c is negative. And then k was the one that has two things, so that does horizontal stretching and shrinking. So it'll be a horizontal stretch if k is a fraction between 0 and 1, or it'll be a shrink, a horizontal shrink, if k is bigger than 1. And the other thing we saw it do is a horizontal flip. And so it will do a horizontal flip if k is negative. And so those are the transformations that take place with sine and cosine. And again, they're just the versions of the one we saw previously in the previous section. I told you when we did that section that we'd be graphing sine and cosine in a similar way, and here we are doing it. So now that we have a decent idea of how those things work, we can write a transformation, right? So let's say a transformation of sine that's been shifted up 10. So up is c, and so c should be 10, right? If it goes left pi, then that means shifting left would be b being negative pi, right? If it's flipped horizontally, then that means k needs to be negative. And if it's stretched vertically, that means a should be 2. And so this transformation right here would be 2 times sine times negative x minus pi plus 10. And to be more clear about that, the 2 is the a, and to be clear, and then to be more clear, I'm plugging these values into the general forms of sine and cosine, right? So we just figured out what a, k, b, and c does in the table, and now I'm applying it here. And so I know that the 2, for example, is the vertical stretching part. We said that a is a vertical stretch, and so the 2 in that one is the vertical stretch. The negative sign right here is flipping things horizontally. The minus pi part is horizontal shift to the left. And then the plus 10 part moves it up 10. And that's what that one looked like. Definitely welcome to ask some questions about this if you're confused, but hopefully you're able to get that one. And then let's think about the second one. So now we're going to do an equation of cosine that's been shrunk horizontally by a factor of 3, down 2, flipped vertically, and shifted by 9. Okay, so let's start with flipped vertically is the one we'll start with because that's a, and that means we want to multiply by a being negative. And so let's do negative cosine because that'll be the vertical flip. And then we want to shrink horizontally by 3. So k does horizontal shrinking, and we want it to be bigger than 1, specifically 3. And so it'll be 3 times x. But then we're going to shift right 9, and so that means going right 9 means b should be 9 then. And so x minus 9. And then if we want to go down 2, that's c, and so we want c to be negative 2. And so that's what that ends up being. All right, so the negative sign is going to flip vertically. The 3 is a horizontal shrink. The 9 move things horizontally shifting to the right. And then the minus 2 is moving it vertical shift down 2. So I hope you sort of understand the general transformations that take place with sine and cosine. I'll just sort of summarize one more time here. This is the general equation of a sine or a cosine, and a, k, b, and c each do one of these transformations, and specifically they do these transformations. And you can always go back onto that Desmos site and practice typing things in and seeing what's what. So for example, let me just show you one of these things being graphed. Let me share my screen one more time. So let's say we come here and let's do a new graph, a new blank graph. And let's graph one of those things we just did. So we graphed 2 sine of minus x minus pi plus 10. And when we do that, you can see it looks like this. And so you can see it's got the sine shape, except it's been flipped. I'm sorry, except it's been stretched, moved up, flipped horizontally, it's done all the things, and that's what this graph would look like. You could do the same thing with cosine. You could do the same thing with any graph to see what it looks like. All right. The second page of these notes talks about some of the physical characteristics of these graphs. Specifically, we're talking about amplitude, period, and phase shift. And here's sort of a general picture explaining each one of those things. And so let's go through them one at a time. So amplitude, you can see, it's the height of one of the peaks of the graph. Or the other way to say that is, it's half the distance between the largest and the smallest value. And so this is a picture that we're thinking about with sine or cosine. We don't know which graph this is, but they both look very similar. The amplitude, you can see, is half the distance of the entire thing, right? And so if the entire, this is the highest point, that's the lowest point, half that distance is the amplitude, right? And you can see it's the size of one of the peaks. The period, we've already talked about that, but that's how long it takes for the function to repeat through its output. In other words, it's how long it takes for the function to start repeating. And so this would be the length of one period, because if we looked at that chunk right there, right, that's one chunk of, say, cosine in this case, and this would be a second period right here. Right, a third period would be over here somewhere. It's kind of cut off, but every time the graph repeats itself, that's one period. So one period, one period, one period. And then the phase shift is just any horizontal shift, and we know horizontal shift is taken care of by the B component in here. And so whatever B is will tell us the horizontal shift. And so maybe let me just add that here. So the phase shift is just any movement left or right of the graph, left or right. And so this is sort of the definition of what those things are, and what it's telling us in this blue box right here is how we actually find those things in one of the functions. And so we know that from the last page, the amplitude is controlled by A. I mean, the vertical stretching or shrinking is controlled by A. And so that's going to control the amplitude in that case then, right? And so that's why it says if we have this general sine graph or this general cosine graph, the amplitude is just the absolute value of whatever A is. And so you think about what A is, and that's going to be the amplitude. Again, the absolute value of it. Since we know that the B controls the K controls horizontal stretching or shrinking, that's going to change the period, right? If we change the graph going like this, that changes the period length. And so whatever K is, the period is 2 pi over K. And then the phase shift, we know that the B component here shifts things left or right, right? So the B does this to the graph, and so that means the phase shift is controlled by B. And so it's really easy to pick out amplitude, period, or phase shift from a function because you just look at A, K, and B, and those will tell you the answers. For example, let's determine the amplitude, period, phase shift, and the specific period interval. Oh, I didn't mention that part. The specific period interval is given by this right here. So an appropriate interval on which to graph one period is this. And so it involves both B and K, because B shifts things left and right, and K horizontally stretches and shrinks things. And so when you change both those things, it changes the period. Right? In other words, this period right here, which is on this graph, is going to change if the graph is stretched or shrinked, or it'll change if it's shifted left or right. And so that's what's going on with the B and the K. Okay, so in one graph of sine and cosine, remember that in these two graphs, we already said that A is 1, right? There's a 1 multiplying those things. The C is 0 in those two functions. The K is 1, and the B is 0. This is what we said. We already said this from the last page, but I'm just sort of reminding you about that here. In other words, right, when you plug into A, K, B, and C, those are the things that you'd have to plug in order to get those two graphs. And so that means the amplitude is the absolute value of whatever A is. And so in this case, A is 1. And so the absolute value of 1 is just 1. And so the amplitude on sine and cosine is 1. The period is 2 pi over k. And we know that k is 1. And so it's going to be 2 pi over 1, which is 2 pi. And we already knew that the period of sine and cosine was 2 pi. So I'm just sort of showing you why the general sine and cosine have those general shapes, right? Excuse me. The phase shift is 0. The phase shift is B, and B is 0, and so the phase shift is 0 in this case. And then the interval of the period involves both B and K, and so we plug B and K into those two spots, and so that would be 0 to 0 plus 2 pi over 1. And when we simplify that, that's just 0 to 2 pi. And we already knew that the general sine and cosine had that interval as well. And of course, the idea is as soon as we start transforming those two graphs, like in this one right here, for example, it changes all those periods and amplitudes and all the things, right? So this one has like a C of 2, this one has an A of -3, a K of 4, right? A B of pi, and so you'll be plugging different numbers into those things, which is going to result in different values. And so that's how we can think about it sort of given a function, or you could think about those things given a graph. So here would be a graph, and we could also think about the amplitude, period, phase shift, and period interval just looking at the picture. Because the amplitude, we said, was half the distance of the height, and so the whole distance of the height is like from here to here, right? And so half the distance would be from here and here. So each one of those things is the size of the amplitude, just looking at the picture. One period would be how long it takes to repeat itself, and so maybe we could start right here and end right here, and so this might be the size of one period. So we could figure out that distance. And then any phase shift would be any shift in the graph. So this kind of looks like a cosine graph to me because it's got the bowl shape and it starts right there. And so we want to think about, did it shift left or right at all? And so when we think about the phase shift, is any shift left or right? So there's two answers or two questions left on this page, and I think you should pause the video and think about them. Plug in A, K, B, and C into these things to find them there, and then look at the graph and figure out if you can think about the amplitude, period, or phase shift. Again, really, really good idea to try this yourself. Remember, productive failure, all these things. When you're doing things online, you really need to take initiative to try these things yourself, and I really hope you do. So pause the graph, give those two a try, and then I'll walk through the answers in just a second here. So I really do hope you walked through those or you tried those yourself. I'm going to walk through them now. So when I'm looking at this particular function here, the A is -3 because it multiplies the signs. So A is -3. The C is what's being added to it, so that's 2 in this case. The K is what's multiplied on the inside here, so K is 4. And then the B is what's being added or subtracted from the X, and so B in this case is pi. And so these are the values that we would use when we fill in the rest of these here. And so I'm going to plug those values into all these things to figure out the amplitude, period, etc. Right? So the amplitude in this first one is going to be the absolute value of A. And the absolute value of A in this case is the absolute value of -3, which is 3. The period involves K. K is 4, and so the period is 2 pi over 4. And then the 2 and the 4 can reduce there to pi over 2. The phase shift depends on b, and so b is pi here, and so the phase shift is going to be pi units to the right, because b is greater than 0. And then the interval we use involves both b and k, so when I plug b and k into here, I get pi to pi plus pi over 2, right? We already know 2 pi over k. We did that right here. We know that's pi over 2. And so that's what it would end up being. And if I want to add pi and pi over 2, we need a common denominator. So that would be pi 2 pi over 2 plus pi over 2, right? I'm just finding a common denominator here so I can add those two things together. And so that's going to be pi to 3 pi over 2. And so that would be the period that we would want to graph this thing on. When we look at a picture, we can just kind of count these things out, right? So the amplitude, again, it's half the distance of the entire height of it, which would be from here to here. And so that's a distance from 1 to 3. So the amplitude goes from 1 to 3, or you could say from here to here, or minus 1 to 1. And so that means the amplitude is 2. The period would be how long it takes to repeat, right? So like this is one period in between my hands right now, because if I slide over, that would be a second period. And so one period would be from, say, here, 0, to here, pi over 2. So from 0 to pi over 2, that's a distance of pi over 2. And so pi over 2 is the period of this one. Right, that distance from right here to right here is pi over 2. The phase shift. So this looks like a cosine graph to me, right? And it says it's cosine actually right here. And so we know that normal cosine looks like this. Starts right here, does the bowl shape thing, comes right back. So it usually starts at 0. Right? It starts right at x equals 0, and this one also starts right at x equals 0, so this one doesn't have any shift left or right. And so b is 0 in this case. In other words, there's no phase shift. Again, because this starts right at 0 where it usually does. If this was shifted over left or right, it would have a phase shift. And then the period interval could be from here to here, or maybe from here to here, whichever one you want. And so I'm going to do the first one. It starts at 0, ends at pi over 2. All right, just to be clear here, it started at 0, and then it ended here. And so this is showing you, based from these things in here, how we can figure out the amplitude, period, and phase shift using either an equation or a graph. There's just one other thing I want to show you, which is the next page, just the last page here, which is one other type of problem you might see in homework and things like that. I'm trying to do problems that you might see in the homework, so the last couple pages I've talked about a couple of them. The last type you might see look like this, where it gives you some functions and then asks you to match it up to some graphs. And you can see in this particular case, we're messing around with sine in all three cases, and we're doing transformations to each one. And so it would be helpful maybe to write down what normal sine looks like, and then think about how each one of these things are different from that. So normal sine goes between -1 and 1. It usually starts here, it goes up to 1, back down to -1, and then back up to 0. It usually crosses right here at pi, and it ends right here at 2 pi. Right, so that's normal sine of t. And so each one of these things has some transformation being done to it that we can relate back to the first page and think about what is being done in that and trying to match it up with the graph. So let's go through one at a time and think about what the transformations are. Again, I would encourage you to do this yourself. and then maybe check your answers. I'm going to go ahead and do it and assume that maybe you've given it a try. Okay, so I'm looking at the general form here from the first page. It looks like this one has a b value of 2. And we know that b does horizontal shifts, excuse me. And so in this particular one, b is -2. I'm sorry. Yes, b is -2 in this case, right? Because the general form, just to be clear here, the general form already has a negative in there. And so if we want a positive in there, then this should have been -2, and then the two negatives create a positive. And so that's why b is -2 in this one. And we know b does horizontal shifts, and so this is telling us to move the graph left 2. This one right here has got a 2 multiplying the t, and so the thing that multiplies the input is the k. And so this one here has a k value of 2. And so we know that k does horizontal stretching and shrinking, and so that particular k does a horizontal shrink by 2 units. This one here is multiplying the sine by 2. And so we know that multiplying the sine is a, and then we know that a does vertical stretching or shrinking from the first page. And so in this case, a is 2, and so that's going to stretch the graph. And so that 2 then is doing a vertical stretch by 2. And then lastly, the +2 is a c value, right? It's being added on the outside, so that looks like this one. And so this one has c equals 2. And so that +2 then is moving the graph up 2. And so we would look for a graph that's been moved up 2. Before we try to match it up to the graphs here, let me just sort of point out these references down at the bottom. These are really just references. There's nothing else here other than just a reference. This is showing horizontal stretching and shrinking and horizontal shifting. So notice that in the first graph, this black one in the middle here is normal sine. And you can see that as we change, we're changing the thing multiplying the x in this. And so if you multiply by a number bigger than 1, the black line shifted in, right? Became the red line. If we multiply by a number less than 1, like 1/2 or 1/3, it takes that black line and it stretches it horizontally that way. So that's showing horizontal stretch. This one's showing horizontal shrink. And then the one at the bottom is showing horizontal shifting. So the shape of the graph doesn't change in both of those cases. The graph is just shifting left or right if you add or subtract values on the inside. So keep that in mind as we try to match up graphs here. So we're thinking about going left 2. Normally this starts at 0, so we would be looking at one that still goes between -1 and 1, but starts at -2 instead. And so I'm looking here, and I'm looking between -1 and 1. It looks like this one still goes between -1 and 1, but it doesn't shift at all. This one's been shifted up. This one's been stretched. This is the one then I think is the one, right? Still goes between -1 and 1. This is -1 here. There's +1 there. Except instead of being over here at 0, this shifted over to the left too. And so this one here would be D. If we're looking for one that's been horizontally shrunk by 2, we would want, instead of being, so it goes half as far, in other words. So instead of going out here to 2 pi, it would be shrunk into pi. So we want the same shape, but just shrunk in. And so that looks to me like A. Right, because A, if we look at the graph of A here, and maybe I should be clear, this one's A, this one's B, this one's C, this one's D, sorry about that. If we look at A here, this is sine, and then it stops here at pi instead of going all the way to 2 pi. And so it's been shrunk horizontally by 2, in other words. If we want one that's being vertically stretched, that's going to be the one that's has the same shapes, doesn't have any shifts left or right, but is twice as high, and so that looks like C in that case. And we can see that because instead of going between -1 and 1 like this graph normally does, it usually goes between -1 and 1, this one goes between 2 and -2. So that's why we can see it's been stretched. And then by process of elimination, we can see the last one's B, but let's just be clear here, right? This one's moved up 2, and so this is the only one that's off the axis, right? This one's clearly been moved up 2. And so that one, one is B. Okay. Wonderful. Let me just sort of add here, I'm happy to go over these, during our class time or office hours or whenever you're available. But just keep in mind that the homework will be on sine and cosine. There is some material here with these trig graphs. There's more trig graphs. I usually don't spend much time on these in general anyway. And since we're on this new online format and I don't have any questions about this in general and homework or anything, I'm just going to go ahead and say that we can skip this page. I'm going to try to pare things down to some of the essentials that we're going to cover, and this just is not one of them. So please keep in mind the Desmos tool that you can use. Let me just show you one more time that it's really, really nice how you can go back to Desmos whenever you want and play around with this Desmos page to try things out, try stretching and shrinking, try moving things left and right. Like we mentioned before, you can plot certain functions and see if you understand them, and all kinds of nice, helpful things. Please, please, please reach out with any questions, and I hope you're able to make our meeting and discuss this.